Okay, so we're looking at homework from section 4.3. This is question number 10. Find the indicated probabilities using the geometric distribution, the Poisson distribution, or the binomial distribution. Then determine if the events are unusual. If convenient, use the appropriate probability table or technology to find the probabilities. And the question is, the mean number of oil tankers at a port city is 12 per day. The port has facilities to handle up to 14 tankers in a day. Find the probability that on a given day, A, 12 oil tankers will arrive, B, at most 3 oil tankers will arrive, and C, too many oil tankers will arrive. So the first thing in this question is we have to decide which type of distribution is this. Is it geometric, is it Poisson, or is it binomial? So we have the mean number of oil tankers at a port city is 12 per day. Per day, that's an interval of time. When we talk about the number of occurrences over an interval of time or space, that's the Poisson distribution. So here we're going to be using the Poisson probability formula. When you're using the Poisson probability formula, you need to know the value of the mean, mu, and the particular x value that you're looking for. So in part A, the mean value is 12. That was in the statement of the problem. But this is also asking about what is the probability that 12 will arrive. So 12 is also the x value here. We look at our probability formula. The probability of x occurrences is mu to the x, e to the negative mu, over x factorial. And we are going to plug in 12 where we see mu and 12 where we see x. So there are going to be a lot of 12s in this equation. So probability of 12 occurrences is 12 to the 12th, e to the negative 12th, over 12 factorial. If we plug that into our calculator, we end up getting 0.1143679155. And the problem wants us to round to 4 decimal places, which would be 0.1144. That's the answer to part A. In part B, we're being asked what's the probability that at most 3 oil tankers will arrive. So at most 3 would be 0 through 3. We can actually use the graphing calculator to help us. There's a built-in function there called the Poisson Cdf Formula. Otherwise, we would have to actually do that same thing that we did in part A for the value x equals 0, x equals 1, x equals 2, and x equals 3, and then add those all together. This Poisson Cdf function will do it for us. So there are 2 different calculator versions out there. They've gone through some upgrades in their software. So depending on what version of the calculator you have, the screens look a little bit different. So we're going to go through what both would look like. They both start out the same way, though. You're going to start by pressing the second function button, and then you'll press the vars button. Once you do that, you're going to be taken to this screen. It's the distributions screen. The second function of the vars button is the distribution screen. You're going to scroll down until you find Poisson Cdf. Once you get to Poisson Cdf, you're going to press enter, and then that's where it changes between the 2 versions of the software that are installed on the calculators. If you have the older version, then what's going to happen when you pressed enter on that Poisson Cdf function, it's going to type the Poisson Cdf function on your screen, but then you're going to be responsible for filling in the rest of this formula. The way you fill in the rest of the formula is you type the mu value, which in this case was 12, and then the x value, 3. Why 3? Well, what the Poisson Cdf formula does is it adds all the different values of x starting at 0 up until the value you tell it to stop at. So we're going to tell it, add up all the values from 0 to 3, stop at 3. So we type in the mu value 12, comma, the x value 3, and then we have to end the parentheses. Make sure that you end those parentheses because the TI-83 and TI-84 graphing calculators are very, very picky when it comes to syntax. Once you do that and press enter, what shows up on your screen should be 0.0022917912, and the problem wants us to round to 4 decimal places, so it would be 0.0023. If you have the newer version of the software, then when you press Poisson Cdf on the distribution screen, what comes up is a Poisson Cdf screen where there's Greek letter lambda, kind of looks like an upside down lowercase y, the Greek letter lambda, x value, and paste. So here what you're going to do is you're going to type your mean value, your mu value, which was 12, where you see the lambda. The x value of 3, you're going to put where it says x value. You're going to highlight paste and press enter. And when you do that on your screen, you get that same 0.0022917912 value, which rounds to the 0.0023. That's going to be your answer to part B. For part C, what's the probability that too many oil tankers arrive? Well, let's read back up in the statement of the problem. The probability that too many arrive, it says the port has facilities to handle up to 14 tankers in a day. Too many arriving would be the probability that more than 14 arrive, because it can handle 14. So more than 14 would be too many. The Poisson Cdf formula function that's built into our calculators always starts at 0 and adds up to a point that we tell it to stop at. We actually want to start at 15 here and add every value going up from there. So 15, 16, 17, up till forever. So this is actually a complement. We're going to do the Poisson Cdf up to 14 and subtract that from 1. So we want to do 1 minus the probability of at most 14 ships coming. So that would be 1 minus the Poisson Cdf of 12, 14. Again, you always have to put in the mu first, and then the x value we want to stop at. We want to add up from 0 to 14, and then we want to subtract that from the 1 to give us 15 or more. Poisson Cdf 12, 14 has a value of 0.7720245328. We subtract that from 1, and we get 0.2279754672. Rounded to 4 decimal places is 0.2280. That's your answer to part C. So the last thing that we're asked is, are any of the events unusual? Is the event in part A unusual, in part B unusual, part C unusual, or are none of the events unusual? Well, our criteria for being unusual was having a probability less than 0.05. Did any of these have a probability less than 0.05? Well, clearly part C doesn't. It's 0.2280. That's on the screen with us right now. If we think back to part A, which was the question about exactly 12 oil tankers arriving, that probability was 0.1144. That's more than 0.05. But the probability from part B, which is at most 3 oil tankers arriving, was 0.0023. That's less than 0.05. So the answer in part B would be unusual because it was smaller than 0.05. And that's your answer.